Welcome back to the deep dive. Today we're looking at something absolutely fundamental, getting safe water. We talk a lot about access, but how do you actually measure it? It's way more complicated than just, ticking a box.
It really is.
Yeah.
And the core issue isn't just, is there water nearby?
Yeah.
It's about the burden, the actual time, the distance, the effort it takes people to fetch it day in and day out.
Yeah, and our sources today take us right into that challenge. We're looking at research from rural Mozambique, Nampula province specifically.
That's right. Researchers there did a deep dive comparing different ways to measure this burden. They looked at straight line distance easy to get from a map versus what people say about their travel time, which is common in surveys.
And the goal here, our mission today, is to figure out how reliable those shortcuts actually are. Because if we use the wrong measurement, well, global health efforts could be way off track.
Exactly. We need to know if these proxies, these easier measurements, truly reflect the reality on the ground. Policy decisions depend on it.
Okay, so let's start with the basics. Why the big push to even include time and distance in the first place? What changed?
Well, the scale of the problem is just immense. Think about it. As recently as 2012, almost half the world's population still had to leave their homes just to get water.
Half the population, that's staggering.
It is. And for a long time, the main global standard for tracking this, the UN's Joint Monitoring Program, the JMP, it had a major blind spot.
Right, I remember this. They basically just asked if people use what was called an improved source.
Yeah.
Like a protected well or something.
Exactly, an improved source. But it completely ignored how far away that source was or how long it took to get there and back. So a village could technically have access, even if the only good well meant hours of walking every single day.
Structurally blind, as you said, and we now know that ignoring that time and distance has serious, massive public health consequences.
Oh, absolutely. This isn't just about convenience. It's literally life and death. The research is pretty clear on this now.
Yeah, tell us about that connection.
Okay, so studies show a really strong link. If you can decrease the one-way walk time to water by just 15 minutes, that's associated with a 41% drop in diarrhea prevalence.
41%, just from a 15-minute shorter walk.
And it doesn't stop there. That same 15-minute reduction is linked to an 11% decrease in mortality for children under 5.
Wow, those are huge numbers. It really underscores that proximity is health.
It really is. And then there are the other costs, the ones maybe less talked about. The physical toll of carrying heavy water containers over long distances year after year that leads to chronic pain, joint damage, injuries.
And it disproportionately affects women and girls.
Overwhelmingly. They do most of the water fetching. And those long walks, often early in the morning or late in the evening, put them at a documented higher risk of gender-based violence.
So the burden is real. Lives, health, safety. It all ties back to this question of distance and time. Which brings us back to Mozambique. How do you measure this reliably across, hundreds of households in remote areas?
Right, that's the challenge. So the researchers in Nampula needed a baseline, a gold standard for what the actual travel distance was.
And they didn't just, use GPS on a phone.
No, much more rigorous. They used high-resolution satellite images, really detailed stuff, sub-meter in some cases.
Okay.
And they literally traced the paths, the dirt tracks, the little roads people actually use to get to their water points. They digitized all of that into a GIS system.
Geographic Information System.
Yeah. And then they used network analysis tools to calculate the shortest actual route from each house to its water source. That measured route distance. That's the ground truth.
Got it. So that's the benchmark. Now let's compare the shortcuts. First up, straight line distance. The kind you'd measure, with a ruler on a map or using a basic GIS tool. Euclidean distance.
Okay, so this was interesting. The correlation between that straight line and the actual winding route people walked was remarkably strong.
How strong?
The R-squared value, which tells you how much one variable predicts the other, was 0.98.
0.98. For anyone not living in stats, that's almost a perfect match, right? It suggests the straight line is a really good indicator.
It's an excellent proxy in terms of correlation. If one goes up, the other almost certainly goes up. But, and this is the really crucial, but the straight line distance consistently underestimated the actual route distance.
Wait, hang on. If the correlation is so high, why the underestimate? Shouldn't they be almost the same number?
Because reality isn't straight. People have to walk around things, fields, trees, buildings. They follow the curve of the land. They use paths that aren't direct. The straight line ignores all of that.
Okay, so how much did it underestimate by, on average?
On average, the straight line distance was 23% shorter than the actual measured rate. That worked out to about 202 meters less per trip on average.
23%. That's not insignificant. If your policy target is, say, 1 kilometer access based on straight line distance, you're automatically missing almost a quarter of the real distance people walk.
Exactly. It's a systematic undercount of the burden. So, GIS, straight line distance. Highly correlated, yes, but it needs adjustment to reflect reality.
Okay, so that's the geographical shortcut. What about the human one? Self-reported travel time, just asking people, hey, how long does it take you to walk there?
Yeah, this is where things get messy. Compared to the reliable measured route distance, the correlation with self-reported one-way walk time was, well, it was terrible.
How bad?
The R-squared value was just 0.12.
0.12. That's basically noise. Almost no predictive power at all. Why are people's estimates so off?
It seems to come down to recall bias. It's a repetitive task, often a tough one. People might remember the really bad trips, the ones that took longer, or, crucially, they might mentally lump together the walking time with the time spent waiting in line at the water point.
Ah, the queuing time.
Exactly. And we know from other studies, like one in Kenya, that people often significantly overestimate how long fetching takes when they self-report.
Okay, so summing up that comparison. Straight line distance is pretty accurate for correlation, but systematically underestimates the actual length. Self-reported time is, frankly, all over the place and generally biased high.
In this rural setting, yes, that's the key finding. The map-based metric is solid, just needs tweaking. The subjective human estimate, not reliable enough for policy, it seems.
But the study didn't stop there, right? They dug into why the self-reports might be off, looking at the details of the fetching itself. And this led to something you called the queuing paradox.
Yes, this was genuinely surprising. The initial thought, the hypothesis, was that spending a long time waiting in a queue would just blur everything together in someone's memory. You'd think it would make their estimate of the walk time even less accurate.
Sounds logical, but not what they found.
The complete opposite, actually. The accuracy of someone's estimate for their walk time actually got better the longer they spent queuing relative to the total trip time.
That feels totally backwards. Why would waiting longer help you estimate your walk better?
Well, the thinking is that the queue acts like a mental marker, a sort of cognitive break. It's a distinctly different activity you're standing still, waiting compared to walking. Because it's so different and often quite long, it might help people mentally separate the walk part from the wait part more clearly.
Huh. So the annoyance of the queue actually helps clarify the memory of the walk. That's kind of ironic.
It is, yeah.
Yeah.
Unexpected benefit of waiting in line, I suppose. Better data for researchers.
Okay, what about the social side? Did fetching water with friends or family change the time estimates?
Interestingly, whether people went alone or with others didn't significantly change the accuracy of their walk time estimate. And this is another nuance.
Go on.
People who fetched water with companions reported, on average, a one-way walk time that was about 5 minutes longer than those who walked alone, even for the exact same route distance.
5 minutes longer just for having company. So maybe walking slower, chatting.
That's the likely explanation.
Right.
Socializing, maybe taking a more leisurely pace. And this brings up a really tricky question for global monitoring efforts, which is, should that extra 5 minutes be counted in the total time burden? I mean, if the goal is just measuring the raw physical effort to get from A to B, maybe not. But if the goal is capturing the total time taken away from other activities, work, school, childcare, then maybe that social time should be included. It's part of the lived experience.
Yeah, that's a tough definitional line to draw. Did anything else affect the accuracy, like education, age, owning a phone maybe?
They looked at all those socioeconomic factors, gender, age, wealth, even cell phone ownership, thinking maybe people use the clock.
Yeah.
But none of them showed a statistically significant link to the accuracy of the time estimates in this particular study group.
So the unreliability seems pretty consistent across different people, at least here. Okay, let's pull this all together. What does this mean for the people actually making policy, classifying communities? How much does the picture change depending on which metric you pick?
Oh, it changes dramatically. It can completely alter whether a region looks like it's meeting its goals or failing miserably. Let's use some standard thresholds people talk about.
Okay, give us an example using distance first, say a 1 kilometer threshold for access.
All right. If you use the easy-to-measure, highly correlated metric straight line distance, you'd classify 79% of the households in this study as having access within 1 kilometer.
79%. Okay.
But if you use the gold standard, the actual measured route distance, accounting for the twists and turns, that number drops to 68%.
So an 11 percentage point drop just by measuring the real path instead of the straight line.
Exactly. Now let's look at time, using a common benchmark like a 30-minute round trip.
Okay.
If you estimate the time based only on the measured distance, using a standard walking speed, sort of a theoretical minimum walk time, about 65% of households would meet that 30-minute threshold.
65%? That's still fairly close to the route distance percentage. But what happens if you use the metric common in surveys, the self-reported total time, which includes their potentially biased walk estimate, plus their reported queue time?
Then the percentage classified as having access absolutely plummets. It drops to just 7%.
7%. Down from 79% using the straight line distance. That's a chasm. Over 70 percentage points difference based purely on how you measure and what you include.
It's massive.
Yeah.
And it perfectly highlights why this isn't just some academic debate about methods. Choosing to measure a straight line versus asking about total time, including queues, gives you entirely different narratives about progress. One says mostly solved, the other says huge crisis.
Wow. Okay. So the takeaway here seems pretty clear. Straight line distance is a useful connected measure, but it undercounts the real walk.
Right. Needs a correction factor.
And self-reported time, at least in this rural context, was just too unreliable, too variable for making these big policy classifications.
That's what this study strongly suggests, yes. So the next time you hear a global statistic about water access, remember just how much complexity, how much debate, how many assumptions are packed into that single number.
Yeah, the difference between 79% access and 7% access isn't just data. It's the gap between a line on a map and someone's actual daily struggle, walking winding paths, waiting in line,
Precisely.
and thinking ahead. We know straight line distance misses things like hills, difficult terrain, dense forests, which obviously slow people down even more than just path winding.
That's right. It underpredicts the route distance, and it doesn't capture the effort related to terrain.
So given that we have better and better satellite data, more computing power, what's the next step?
Well, that's the big question, isn't it? How can we leverage technology, smarter GIS, maybe AI analyzing satellite imagery, to create distance or even effort estimates that automatically account for terrain, elevation gain, land cover, the actual winding paths, without having to manually measure every single route or rely on flawed self-reporting?
So bridging that gap between the view from space and the reality on the ground.
Exactly. Making the technology reflect the true human burden. That's really the challenge for ensuring equitable water monitoring going forward.